Hello learners, welcome to the next module of quantum computing. Here we are going to discuss about the quantum data set. So in this session we are going to discuss about quantum data set, types of quantum data set, hybrid quantum classical models and application specific quantum data set. So the first, what is quantum dataset? A quantum dataset is structured collection of quantum data used for training, testing or operating quantum algorithm. Unlike classical dataset which consists of numerical or categorical values stored in database or files, quantum datasets store in information in quantum state or hybrid classical quantum format. Quantum datasets comes in various forms including pure quantum state, hybrid classical quantum formats and application specific structure. As quantum computing advances, the development of quantum dataset will be critical in powering quantum machine learning, optimization and simulation of application. Characteristics of quantum dataset can be composed of pure quantum state, mixed state or hybrid classical quantum data. Used in quantum machine learning, quantum neural network, quantum optimization. Requires specialized quantum memory for this process, hybrid storage for efficient process. We can go with a different kind of quantum feature encoding also to be included. Here amplitude encoding and angle encoding is the best choice. So common representation of quantum dataset here is, first one is pure quantum dataset, fully quantum representation where each data sample is stored as a quantum state. The next is hybrid classical quantum dataset, classical data embedded into quantum states for quantum enhancement learning. And the third is quantum embedding, data transferred into high dimensional quantum state for feature extraction. Next is types of quantum dataset. Quantum datasets are categorized based on the structure, use case and whether we can go with a different kind of information, and it may be a mix of classical quantum data also. The first one is pure quantum dataset. These datasets contain only pure states and are processed directly on quantum hardware. The first one is quantum state dataset. It contains labeled and unlabeled data used in quantum generative models, variational quantum algorithm and quantum kernel methods also. And here we can go with a simple representation of Bell states of quantum inputs, ket beta 00 which is equal to ket 00 plus ket 11 divided by root 2. So the next thing is quantum entanglement dataset. Stored entangled states and are used to study quantum correction, quantum correlations. Example, we can go with different kind of gates cluster states used in quantum communication. And the third is quantum circuit dataset. Stored predefined quantum circuits rather than the states used in quantum neural networks for learning quantum function. The third next case is hybrid quantum classical models. A quantum model can be represented and generalized data with a quantum mechanical origin. Because near-term quantum processors are still fairly small and it is too noisy, quantum model can't generalize the quantum data with the help of quantum processor. So we can have a processor, different kind of processor. Here NISQ processor must work with a different kind of classical coprocessor become effective. So we can also go with the TensorFlow. Already it's supported by heterogeneous computing across GPU, CPU and TPU. It is also used for the base platform for quantum classical algorithms. And the second part is hybrid classical quantum dataset. These dataset mix classical and quantum information and are used in quantum machine learning QML. Quantum encoded classical dataset. Classical data converted into quantum representation using encoding techniques like angle encoding and amplitude encoding and Q-sphere representation. Here we can have a different kind of data sets. Here MNI is data set converted into quantum states for quantum classification. So further we can go with variational quantum dataset. Use quantum classical hybrid approach where quantum circuits generate data samples for classical post processing. Example, we can go with weak EU dataset for molecular simulation. And the third is about quantum kernel datasets, classical data transferred into high dimensional quantum feature space for quantum enhancement machine learning. So here we can go with the quantum support vector space. So the third case is we are going to discuss about application of specific quantum datasets. These are designed for specific domains such as quantum chemistry, quantum finance, and quantum cryptography. In case of chemistry dataset, we can go with the molecular Hamiltonians and quantum states for molecular systems. Example quantum datasets used in Qiskit nature for simulating molecules like H2 and LAH. Quantum finance dataset used for quantum risk analysis, portfolio optimization, and Carolo simulation. Example, we can go with the estimation dataset for pricing model. And the third is about encoding. It's a process of transferring information into a specific format for efficient processing and storage and communication. So encoding is widely used in various fields such as computer science and telecommunication and data compression. So we can go with a different kind of classical encoding is there. We need to know that before entering into quantum encoding. Text encoding is there, convert the character into binary code. And image encoding represent the image into binary format. And data compression encoding reduce the data size for storage or transmission. Error detection and correction encoding methods also is there to integrate all the redundant information. Cryptographic encoding transfers data into so secure format. And the next thing is quantum encoding. This is very important process of encoding classical or quantum information into quantum states using qubits. Unlike classical encoding, which is deterministic, quantum encoding takes advantages of quantum properties such as superposition, entanglement, and interface to store and process the data. So key features of quantum encoding is superposition, entanglement, quantum gates, measurement of collapse. So in superposition, both zeros and one are to be considered simultaneously. Entanglement, correlated qubits share information in a way, and quantum gates encoding often requires applying quantum gates, and in the last case we can easily collapse with classical bits. So type of quantum encoding, the first basic one is basic encoding, computational basic encoding. Here maps the classical bits 0, 1, 0, 1 and 0, 1 directly onto qubits. So 0 is represented as get 0 and 1 is represented as get 1. This is very simple for quantum circuits and quantum communication. And for amplitude encoding, we can have a normalized classical vector is there, and phi get phi, which is equal to x1 get 0 plus x2 get 1 up to xn get n. So it is a representation of quantum state where classical data is x1, x2, x3, and quantum basic state is get 0, get 1 up to n. So this is a very simple way of representation of quantum machine learning because it is a compresses of large amount of classical data. Thank you learners. We will see in the next session.